So my name is Patrick Buikema. I'm a graduate student researcher in the Center for Neuroscience at the University of Pittsburgh. I think the bottom line is when you think about the brain, it's hard not to be interested in the brain, right? Because it's how we experience the world, and yet once you start getting into the getting into the study, you realize we really have very limited understanding of a lot of complex phenomena. And that's like kind of shocking, like we experience the world as just a series of electrical impulses. That's every single experience you've ever had is just a population of neurons firing, which is kind of mind-boggling when you think about it. You think you're experiencing the world in real time, but you're not. You're experiencing in the past, and it's just the result of electrical activity in your brain.
How does the brain compartmentalize as a biological organ? Just think about this for a second. Our oldest thoughts are somehow at the end of this linear type archive that somehow knows exactly how to categorize and retrieve at any whim. Really, it's a phenomenon that is so taken for granted that we simply conform to the molds that we are placed into. Is the brain really equipped with a storage bank and a command center? The reason I ask is there's some sort of transcendental nature about the brain that allows it to function as a complex biological organism under some sort of spiritual control mechanism, or we really don't seem to understand. Yet science and the medical field operate as if they were the world's authority on the matter. But clearly there's more than meets the eye. So let's explore what the brain truly is and attempt to unravel its mystery. And with an open mind, we can establish a correct filter of interpretation.
You've heard people say it's just like riding a bike, meaning it's really easy and you can't forget how to do it, right? But I did something that damaged my mind. It happened on the streets of Amsterdam, and I got really scared, honestly. I can't ride a bike like you can anymore. Where I work, the welders are geniuses and they like to play jokes on the engineers. He had a challenge for me. He had built a special bicycle and he wanted me to try to ride it. He had only changed one thing. When you turn the handlebar to the left, the wheel goes to the right. When you turn it to the right, the wheel goes to the left. I thought this would be easy, so I hopped on the bike ready to demonstrate how quickly I could conquer this.
And here he is, ladies and gentlemen, Mr. Destin Sandlin. First attempt riding the bicycle. Yeah.
I couldn't do it. You can see that I'm laughing, but I'm actually really frustrated. In this moment, I had a really deep revelation. My thinking was in a rut. This bike revealed a very deep truth to me. I had the knowledge of how to operate the bike, but I did not have the understanding. Therefore, knowledge is not understanding. Handlebars, gyroscopic precession in the wheels, every single force is part of this algorithm, and if you change any one part, it affects the entire control system. I do not make definitive statements that often, but I'm telling you right now, you cannot ride this bicycle. You might think you can, but you can't. This guy, I offered him $200 just to ride this bike 10 feet across the stage. Everybody thought he could do it.
No, you didn't understand. So, this way. All right, just a second. All right, so, whenever you're ready, yeah. Wait. No, you have to keep your feet on. Dude, look. All right, here we go. Just give me Wait. Like, you gotta start rolling at least. And go. Oh, go! All right, back up. Okay, keep your feet on the pedal. Go. Go right on. Just keep your feet on the pedals. Hands on. Yeah, come on. All right, one more time. Okay.
Once you have a rigid way of thinking in your head, sometimes you cannot change that, even if you want to. So here's what I did. It was a personal challenge. I stayed out here in this driveway and I practiced about 5 minutes every day. My neighbors made fun of me. I had many wrecks, but after 8 months, this happened. One day I couldn't ride the bike and the next day I could. It was like I could feel some kind of pathway in my brain that was now unlocked. It was really weird though. It's like there's this trail in my brain, but if I wasn't paying close enough attention to it, my brain would easily lose that neural path and jump back onto the old road it was more familiar with. Any small distractions at all, like a cell phone ringing in my pocket, would instantly throw my brain back to the old control algorithm and I would wreck. But at least I could ride it. My son is the closest person to me genetically, and he's been riding a normal bike for 3 years. That's over half his life. I wanted to know how long it would take him to learn how to ride a backwards bike, so I told him if he learned how to ride a backwards bike, he could go with me to Australia and meet a real astronaut.
You gonna give up? Go ahead. This is how it starts. Look at this. This is such a big deal. Get up, you got it. Did you see his brain get it? So he, in, how many weeks have we been doing this? 2 weeks? In 2 weeks, he did something that took me 8 months to do, which demonstrates that a child has more neuroplasticity, am I even saying that right, than an adult.
It's clear from this experiment that children have a much more plastic brain than adults. That's why the best time to learn a language is when you're a young child.
All right, today's bike log. I can ride smooth, I can ride fast. I'm thinking the experiment is over. Okay, now I'm in Amsterdam, a city that has more bicycles than people. The question is, can I ride a normal bike now? I mean, I've spent all this time unlearning how to ride a bike. If I go back and try to ride a normal one, will my brain mess up? So I've tweeted a Smarter Everyday meetup, if you will, and I'm gonna see if somebody brings a bicycle and I'm gonna try to ride a normal bike. It's backwards, it's backwards.
This was one of the most frustrating moments of my life. I had ridden a normal bike since I was 6, but in this moment I couldn't do it anymore. I had set out to prove that I could free my brain from a cognitive bias. But at this point, I'm pretty sure that all I proved is that I can only redesignate that bias.
So what you're not seeing is just a group of people here looking at me, looking at the strange American that can't ride a bike because they think I'm dumb. But I'm actually 2 levels deep into this because I've learned and unlearned. All right.
After 20 minutes of making a fool out of myself, suddenly my brain clicked back into the old algorithm. I can't explain it, but it happened in a very specific moment.
Got it. I'm back. Oh, click. Hold it, click. I got it. Okay, there it is. There was the moment. Okay, I can ride a bike.
I tried to explain this to the people around me, and they just didn't get it. They thought I was faking the previous 20 minutes, and I couldn't get anybody to believe me.
That looked like I faked that, didn't it?
Yeah.
Just a fake. You think I'm faking. You don't believe me.
That looks so weird. You were like, la la la, and it's full.
You think I'm lying, don't you?
Yeah, I did.
I'm not lying.
I felt like the only person on the planet who had ever unlearned how to ride a bike, and I couldn't articulate it to anyone because everybody just knew that you can't forget how to ride a bike. So I learned 3 things from this experiment. I learned that welders are often smarter than engineers. I learned that knowledge does not equal understanding. And I learned that truth is truth, no matter what I think about it. So be very careful how you interpret things because you're looking at the world with a bias, whether you think you are or not. I'm Destin. You're getting smarter every day. Have a good one.
So how do we learn? And why do some of us learn things more easily than others? So brain research is one of the great frontiers in the understanding of human physiology. What we know about the brain is changing at a breathtaking pace. And much of what we thought we knew and understood about the brain turns out to be not true or incomplete. Now, some of these misconceptions are more obvious than others. For example, we used to think that after childhood, the brain could not change. And it turns out that nothing could be farther from the truth. Another misconception about the brain is that you only use parts of it at any given time and it's silent when you do nothing. Well, this is also untrue. It turns out that even when you're at rest and thinking of nothing, your brain is highly active. So it's been advances in technology such as MRI has allowed us to make these and many other important discoveries. And perhaps the most exciting, the most interesting and transformative of these discoveries is that every time you learn a new fact or skill, you change your brain. It's something we call neuroplasticity. So as little as 25 years ago, we thought that after about puberty, the only changes that took place in the brain were negative. The loss of brain cells with aging, the result of damage, like a stroke. And then studies began to show remarkable amounts of reorganization in the adult brain. And the ensuing research has shown us that all of our behaviors change our brain. That these changes are not limited by age. It's good news, right? And in fact, they're taking place all the time. The key to each of these changes is neuroplasticity. So what does it look like? So your brain can change in 3 very basic ways to support learning. and the first is chemical. So your brain actually functions by transferring chemical signals between brain cells, what we call neurons, and these trigger a series of actions and reactions. So to support learning, your brain can increase the amount or the concentrations of these chemical signaling that's taking place between neurons. Now, because this kind of change can happen very rapidly, this supports short-term memory, or the short-term improvement in the performance of a motor skill. The second way that the brain can change to support learning is by altering its structure. So during learning, the brain can change the connections between neurons. Now here, the physical structure of the brain is actually changing, so this takes a bit more time. These types of changes are related to long-term memory, the long-term improvement in a motor skill. Now, these processes, they interact, and let me give you an example of how. So we've all tried to learn a new motor skill, maybe playing the piano, maybe learning to juggle. You've had the experience of getting better and better within a single session of practice and thinking, I've got it. And then maybe you've returned the next day and all those improvements from the day before, they're lost. What happened? Well, in the short term, your brain was able to increase the chemical signaling between your neurons. But for some reason, those changes did not induce the structural change that are necessary to support long-term memory. Remember that long-term memories take time, and what you see in the short term does not reflect learning. It's these physical changes that are now going to support long-term memories and chemical changes that support short-term memories. So neuroplasticity is supported by chemical, by structural, and by functional changes. And these are happening across the whole brain. They can occur in isolation from one another, but most often they take place in concert. Together they support learning, and they're taking place all the time. One thing is absolutely clear. The best driver of neuroplastic change in your brain is your behavior. So the first lesson is that the primary driver of change in your brain is your behavior. So there's no neuroplasticity drug you can take. Nothing is more effective than practice at helping you learn. And the bottom line is you have to do the work. And in fact, my research has shown that increased difficulty, increased struggle, if you will, during practice actually leads to both more learning and greater structural change in the brain. The problem here is that neuroplasticity can work both ways. It can be positive. You learn something new and you refine a motor skill. It also can be negative though. You forgot something you once knew. You become addicted to drugs. Maybe you have chronic pain. So your brain is tremendously plastic and it's being shaped both structurally and functionally by everything you do, but also by everything that you don't do.
The Avatar movie is an interesting analogy of what some people are saying about the consciousness transcending the brain and the body. But to reflect on the last two video clips, it's apparent that the mind is something that tells the brain and body what to do, and the body then responds. It is clear that it isn't so simple, considering neural plasticity. If the brain has neural pathways that are created by repetition and training, the memories are formed and habits become second nature. The question also comes to mind, what is first nature? And how is their cellular memory ingrained in DNA? This is the natural instincts that we are all born with. Except there is no one person that is the same. We are all unique, like a snowflake. Is there a frequency that is above our ability to perceive, that controls the design of everything and guides its path of development? How would everything have individuality, even down to a single snowflake?
Laurel, 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 Laurel.
When saying there's more than meets the eye, clearly that is an understatement. With some of these illusions, you will think that your eyes are playing tricks on you. But really, it is our mind's limited ability to be able to process through certain information. Also, bias will factor into how someone interprets the information in their mind. Being able to perceive is a phenomenon in itself. but it seems as though perspective is relative to the observer, such as the Yanny and Laurel thing before this. It seems that the human brain tunes into some sort of frequency, and it will interpret things the way that our brain has been trained to interpret. So by our very nature, we are trained to be biased. But there is also a part of us that seems to transcend our ability to perceive, as if we are more than our own brain's perception. There seems to be a higher consciousness that controls thoughts and how we perceive. I don't think that it can just be written off as a synapsis in the brain or just firing of neurons. There is something much more vast. When I consider the reality that we live in, it seems much more like this matrix type reality the more I think about it. Our brains and our bodies are set up with some sort of limitations, and this transcendent consciousness controls the rest, like a remote control car or something like that. The theme that I see with the quote-unquote experts in the field of the brain and neuroscience is they don't really know the inner workings or complexity of the brain. It seems that they can only identify to patterns.
I'm looking forward to meeting Kim Peek because he's meant to be amazing. He was the guy that the Rain Man character was based on. This is really exciting for me because it's my first time meeting someone else with whom I have this bond.
Daniel makes his way to Salt Lake City's pub. Him and his father are waiting for him.
Hello, nice to meet you too.
Let's walk down in here and we can have
They head off to a quiet corner, where Daniel can find out more about Kim's stupendous memory.
time they moved in there. With total photographic memory, he remembers everything he's ever read. He can tell you every city in the United States, its highways and its area codes and its zip codes and its television stations and its counties and when it was made a state. The history of any country, all the rulers and when they served, presidents of this country, when they were born, their wives, their families, all of NASA's accomplishments, when they went up, when they came down, what they're doing. He can talk to you about the Bible, he can quote scriptures, he can tell you anything about it you want to ask him about. It seems like everything he reads, he maintains. At 9 months, the neuropsychiatrist said he's severely mentally retarded. He will never be able to learn. You should put him in an institution, forget about him.
But Kim was reading encyclopedias by age 4 and had finished the high school curriculum by 14.
Goodbye, old pain. I'm a leaving Cheyenne. You know that?
How fast can he read?
He reads a page that you and I would read in 3 minutes approximately. It takes him about 8 to 10 seconds. He reads the left page of the left eye, right page of the right eye, and remembers about 98% of it.
Go back through here.
Kim, my birth date is January 31st, 1979.
It was a Wednesday, and this year it's a Saturday. We turned 2044 on a Sunday.
What year did Queen Victoria become Queen?
1837 to 1901.
Kim, if Winston Churchill was alive today, how old would he be?
130.
And what day of the week would his birthday fall on this year?
It would be on a Tuesday, the last day of November.
In 1987, Kim met actor Dustin Hoffman and became the inspiration for the hit movie Rain Man.
We went to Hollywood the next morning and Kim spent the day with Dustin and all of his film friends. And it was amazing, all the things they asked him and all the things he knew. It was just like I hadn't known him before. There were so many new things that came out of him.
Although I'm much older, you're still a fine man.
Thank you. So are you.
Yes.
Disney says you don't have to be handicapped to be different, because everybody's different.
Scientists have tested Tammet's memory. They had him take a look at pi, a string of numbers that goes on forever.
You read through them once?
Yeah.
And that was it, you've memorized it?
And that was it, one time only.
He memorized the first 22,000 digits of pi.
4, 1, 5, 9.
And then, in front of a disbelieving audience, he begins reciting the numbers back, in order, from memory.
5, 7.
5 mathematicians struggling to keep up, checking every single digit.
2, 5, 9, 0.
It's mesmerizing.
3, 4, 6, 9, 0, 8, 1, 9, 9, 0, 6.
After 5 hours and 9 minutes.
Finished, yeah.
Every single one. Perfect.
I learned to count like anyone else at a young age, and when I did, I would see colours, I would see pictures in my mind. I assumed at the time that everyone saw numbers as I did.
Tammet didn't do math like the teacher said. The answers just came to him. Watch how he finds the answer to 53 times 131.
With a sum like 53, just round, very round, answer at the bottom, and then you've got another number here, 131, which is longer, a little bit like an hourglass, symmetrical, and in the middle you've got a negative space, then you have a third shape, and this I see is the solution to the sum, 6, 9, 4, 3.
For Tammet, every digit is a 3-dimensional shape. 9 is large, deep blue, concave. 4 is small, light blue, angular. 10 is like a metallic puddle. To memorize a long number like pi, he just forms a beautiful landscape out of those shapes.
It's a world, it's a novel world.
A world science cannot fully understand. Tammet has Asperger's syndrome, a form of autism that makes him unnaturally obsessive, focused. He also has something called synesthesia. In a normal brain, different parts don't talk to each other. In Tammet's brain, they do. That's why he sees numbers as beautiful shapes and colour. They call Tammet an autistic savant, like Rain Man.
Do you know how much the square root of 2,130 is?
46.15192304. 2304.
Most savants, like Dustin Hoffman's character, find normal life social interaction almost impossible.
Were you bullied at school?
Yes, I would have gestures, flapping of the hands, for example, walking in circles, and the other children would repeat that back to me, tease me, call me names.
But these days, crowds flock to hear Tammet speak.
The most extraordinary brain. His name is Daniel Tammet.
I realised, that I had something within me that was special and was a gift, and I should use it to the best of my ability to make a difference.
His autobiography is a bestseller translated into 20 languages. A second book details how our brains really work.
I'm able to look from the inside out, and so that gives a new perspective that scientists haven't had before.
Tammet is also a role model for having overcome the crippling limitations of autism.
It's never easy. I think there's always an effort there.
He trained himself to make friends, tell jokes, stuff that for most of us is second nature.
Le jus d'orange.
But he still can't drive a car.
What's the obstacle there?
The obstacle there is the amount of detail that my brain will pick up. And it's beautiful, but it's not safe for driving.
Tammet, born the eldest of 9 children in England, now lives in Avignon in the south of France, where popes lived in the 14th century. Van Gogh painted the surrounding countryside.
Bonjour. Bonjour. There's meat, cheese, which is of course famous.
He's embraced the French joie de vivre.
And we eat lots of fish, very good for the brain.
I'm not sure you need that, do you?
Who knows?
Because not only are numbers a gift, but so are words. He knows 8 languages, and we watched him pick up one more. off to Reykjavik, Iceland, where Tammet touches down with a final challenge to learn Icelandic, perhaps the most impenetrable language on Earth. For example, remember the name of that Icelandic volcano that was in the news? He'll have just 1 week to learn the language.
Impossible for a human to learn this in a week.
When people say to me, this is something you can't do, I want to do it. I want to prove them wrong.
He was like a vacuum cleaner. I can see it. He was sucking up the words, and he was just putting it in his brain.
After just 7 days of studying, has he cracked the code?
Okay, tell me when to go on.
Tammet appeared on Icelandic TV, a live talk show.
Velkomin. Hvernig hefur gengið að læra?
Mjög vel, takk. Íslensk fyrir mig så falleg.
Holy cow, he nailed it.
It's not human.
No, it's not. Daniel Tammet is superhuman, and science can't quite figure out why.
So, Daniel, the question everyone wants to ask you is, how do you pronounce the name of that Icelandic volcano?
Eyjafjallajökull.
That's hard.
To recap a little bit on all the areas that we've covered on the brain and neuroplasticity and all the other neural functions of the human brain, it can be difficult to draw conclusions when there are so many things to consider. It seems safe to assume that we cannot know everything about the brain. Really, drawing conclusions is like making assumptions that we do have all the answers when we really don't. In the beginning clip, when that doctor from the University of Pittsburgh was describing neurosynapses or firing of electrical signals, is how the brain interprets and processes reality. That is like likening the human brain to a computer or a robot or some sort of electrical device when we are actually so much more complex than that. I'm gonna project my bias and say that there is no way that the human brain could have evolved over millions of years by random chance. All the patterns that I see in this reality point to there being an intelligent creator, someone or something that is far more superior to our intellect and capable of creating such complexity. The brain is just one aspect of that complexity. I want to point out the vast complexities of everything that is in this reality. Everything that seems so meaningful and beyond us. The fact that we can analyze the things around us and analyze the human mind or brain begs the question as to why. Why are we here? What is the meaning of everything? It's almost as if we are supposed to ask the question, why? And what is so important about figuring these things out? I think that there is something underlining from within our being that is sending us a signal or a message to draw us in and seek out the answers. Some of us have that drawing more than others. I'll tell you right now, this is the goal of my life. And I'm gonna get down to the bottom of it, one way or the other.